Welcome to this presentation on C++ build systems. We'll explore how to streamline C++ project development with modern build tools. Let's dive in. The icons that we will be discussing in this presentation are CMake, Make and general build tools. Let's consider why build systems are essential in C++ development. C++ development presents several challenges, including managing complex dependency trees, tracking which files need recompilation, handling platform-specific compilation flags, integrating third-party libraries, and coordinating build steps across large projects. Build systems automate the build process. The build process starts with source files, that is, .cpp and .h files. These files undergo preprocessing followed by compilation, which produces object files, that is, .o files. Finally, the object files are linked to create an executable or a library. Here are some popular C++ build systems. First, we have Make, a traditional build system dating back to 1976. It uses makefiles to define build rules and dependencies, and is still widely used in many C++ projects. This is an example of a simple makefile. Second, we have CMake, a cross-platform build system generator. It generates native build files like makefiles or Visual Studio projects. It simplifies dependency management and configuration. This is an example of a CMakeList.txt file. Let's explore more C++ build systems. First, we have Ninja, a build system focused on speed. It is much faster than Make and is designed for use with a higher-level build system, often used as a CMake generator. This is an example of a build.ninja file. Then we have Bazel, Google's open-source build system, designed for large multi-language projects. It focuses on reproducible and fast builds. This is an example of a build file for Bazel. Let's walk through the basic CMake project workflow. The first step is to configure the project. Create a build directory and run CMake to generate build files. Here is an example of the commands. The second step is to build the project. Compile the project using the generated build files. Here is an example of the commands. The third step is to install or package the project. Install the built targets or create packages for distribution. Here is an example of the commands. A well-organized CMake project structure makes it easier to manage dependencies and build configurations. On the left, you can see an example project directory structure, including a root CMake list file, include directory, source directory, and test directory. On the right, you can see example code for a root CMakeList.txt file. Let's see the advanced CMake features. Firstly, managing dependencies. You can find and use external libraries with the find package command. You can also use fetch content for downloading dependencies at configure time. External project is used for more complex dependency management. This is an example of finding an external package. Secondly, modern CMake best practices include using a target-based approach with target commands. Control visibility with public, private, and interface. Create interface libraries for header-only libraries. This is an example of a modern target-based approach. Here is a comparison of different build systems. Considering the ease of use, Make and Ninja get 2 out of 5 stars, while CMake and Bazel get 3 out of 5. In terms of build speed, Ninja gets 5 out of 5 stars. Considering cross-platform, CMake gets 5 out of 5 stars. And finally, considering dependency management and large project scalability, Bazel gets 5 out of 5 stars. Note that ratings are subjective and may vary based on specific project requirements and team expertise. Here are some best practices and resources for C++ build systems. Adopt a modular organization, structuring your project with clear separation of concerns. Integrate version control, keeping build artifacts out of version control. Implement continuous integration to automatically build and test your project. Here are some learning resources. The CMake documentation at cmake.org/documentation. The Modern CMake Guide, and C++ Best Practices. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.